Welcome to the comprehensive Windows x86 malware analysis bootcamp. I am Ankit, and before we dive in, I want to give a special shout out to Josh Reynolds, founder of InvokeRE. Much of what I'll be sharing today comes from his excellent course, Introduction to Malware Binary Triage. You'll find the link in the description below. You have two options, either you go with the IDA or you go with Binary Ninja. Both are great, do check out. Let's start. Malware analysis isn't just about understanding code, it's about outsmarting digital threats that evolve faster than you can say cyber security. In this video, we are going to crack open the hood of malicious software, peek at its inner workings, and start building the skills you need to become a formidable malware analyst. By the end of this session, you'll have hands-on experience with initial analysis techniques and a solid grasp of the fundamentals. Now, let's dive into the dark and intriguing world of malware. Malware isn't just a fancy term for computer bugs. It's software designed with malicious intent, and it comes in various flavors. First, we have viruses. These are digital parasites that attach to files and spread faster than office gossip. Worms, self-replicating programs that slither through networks uninvited. Then we have Trojans, the ultimate digital con artist pretending to be legitimate software, but they are not. Ransomware. These are really popular. The digital equivalent of kidnappers holding your files for ransom. Then we have spyware, the nosy neighbor of the digital world, always peeking at your data. Basically aligns with the government, right? Then we have rootkits, the ninjas of malware hiding in plain sight on your system. Now, why should you care about analyzing this digital rogue gallery? Because understanding these threats is crucial for building better defenses, understanding your enemy, responding to incidents, and sometimes even catching the cyber criminals behind them. Before we get our hands dirty, let's decode some key terms. Think of this as your malware analysis dictionary, which you keep on improving. First, we have file size versus size on disk versus image size. You might have seen file size on disk, but what about image size? So, file size is the actual size of the file's content. Basically, right-clicking on a file if you want. This is what I'm talking about. Right-click on the file.txt, click on Properties. There are two options. First is the file size, which says 9 bytes. Second is the size on disk, which says 0 bytes. So what is the difference? And we don't see image size here. Now, size on disk is how much space the file hogs on your hard drive, often larger due to storage allocation. Image size for executables, it's how much memory the program occupies when running. Then second, we have x86 versus x64 architecture. x86 is 32-bit architecture. Think of it as a highway with 4 billion lanes. Whereas x64, imagine that same highway but with trillions of lanes. On third, we have PE format. This is the blueprint for Windows executables. It tells the operating system how to handle the file. Now, what this means, we will understand when we go through the PE file format. On fourth, we have binary versus non-binary files. Now, this looks silly, right? What is binary versus non-binary? But it's not. So, what is a binary? Files that speak computer. Example, a .exe file or .dll file. These are binary. Non-binary files that speak human, high level, example .txt, or even a Python script because it speaks our language. It's not really a binary right now. Later onwards, you could make a binary out of it. You could use a tool called PyInstaller. You get the exe file out of it. Then on fifth, we have file types. Under file types, there are different extensions. Now these are limited, but you might encounter terms like .exe, .dll. .exe is executable files, the ones that make things happen. .dll are dynamic link libraries, the supporting actors of the software world. Sometimes exe file doesn't really have something which is required for its functioning, so it tries to import that functionality from a different file. In Windows, those files are DLL files. Now, we see PE versus binary. All PE files are binaries. PE is portable executable, but not all binaries are portable executable. What does this mean? It's confusing, right? It's like how all squares are rectangles, but not vice versa. If you want, you can share some more insight on this particular line. Do comment if you feel. On 7th, we have sections of a PE file. Different neighborhoods inside a PE file. That's what section is. Each has its own purpose, like .text for code and .data for, well, data. Imports and exports. Imports are functions a program borrows. Exports are functions a DLL lends out. The same thing which I discussed earlier. Then we have hashing, creating a unique digital fingerprint of a file. This is crucial for identifying known malware. Now, here's the kicker. In this course, we are focusing on Windows x86 PE malware. But malware is like a chameleon. It can take many forms across different platforms. Let's talk safety. We are doing all our analysis in a virtual machine. Remember that, a digital sandbox where we can play with malware without risking our main system. Always practice safe analysis. But do remember, even the digital sandbox is not safe. There are some malwares which can even affect the sandbox. So keep that in mind. Time to get our hands dirty. We'll be going through two tools. First is the PowerShell, and on second we have DIE, which is short for detect it easy. Now let's start. We'll be using the command to get the file hash first, which is get file hash. Now this is the hash, and here it says algorithm SHA-256. We have other algorithms too, which are SHA-1, MD5, but this is the one which is standard right now. Now, to get the strings, there is a command called string. Then you give the exe file. If you click, you get the strings in the PowerShell. At the top, you see this program cannot be run in DOS mode. What is this? And this is really common. Then we have .text, .data, .rdata, .idata. Then we have something like .bss also. That's it. So if you start analyzing like this, you might get some IOCs out of it. It could be IP address. It could be some file name, some unique random name. So this is actually static analysis, basic static analysis. Now we'll go through the other tool, which is called DIE, and inside DIE we'll be loading. Do remember, this advanced option should be enabled. We'll be opening our harmless malware. See, if I click on advanced, we'll lose some options, so we need those options. Now we will go through the file overview here. At the top, we see basic file information like size, type, architecture. This gives us a quick snapshot of what we are dealing with. Example, if we go through it, here we see P32 file size, and then we see size of image. If you right click here, you see 69632, which is a different format. This is the time date stamp. Under section, you see something. Then there is NDNS. We have two NDNS. One is big, one is little. This is 32-bit. Architecture, Intel i386. Type is console. And we have the base address here and entry point. We'll be clicking on P now. PE gives us more insight. Example, if we start from info, this is the same details, virus total. Then we have the hex details. There we see MZ. This program cannot run in DOS mode, which we saw earlier. Now, if you click on disassembly, we get to see the disassembly view of the same. And for this process, we have specialized tools called disassemblers. One of them is Binary Ninja and the other is IDA. See, these are some instructions. Like if you have seen coding in Python or C or Java, we have some commands there. These are the commands used in assembly language. Now we don't need to get involved in this right now. We'll go directly to the hash. Here you can see the hash. The method is MD5. If we click on SHA-256, we get to see the hash now. The strings. Under this also at the top we see this program cannot run in DOS mode. And if we go through it, let's say we are interested in looking at a particular IOC. So let's write .com. Just by writing .com, we get to see one website called c2.FAUT.L. I'm pretty sure it's not this easy, but still, if you try looking for some keywords, you might actually get something out of strings itself. If we click on signatures, then we have memory map. Can you recall this address? What is this address? Look at the base address. Base address is 400, and here if you see, this is the address. So this means this is the P address starting. It's its base size 000040, and then that same size is the offset for this, which is basically the difference. After this, we see the sections starting. First is the .text, .rdata, .idata, CRT. Okay. At last we see overlay. Now we'll be looking at entropy. Entropy is the randomness of a file, which is really important. But right now we don't need to get involved in this. We'll go to the DOS stub. Okay. Again, you can recall the same. Now we can go directly to the optional header. This is the optional header. Under this you see really important information like major linker version, minor linker version, size of code, pace of code. And if you click on image directory, you get to see the export, import. If you click on sections, you get to see all the sections which we discussed. Example, .text, .data. Again, here you see the virtual size, virtual address. There is a option called import. If you click on import, you get to see all those DLL files which are getting imported by the executable when the executable is running. These are all system related files. Think about a situation where the malware author is trying to manipulate the DLL files. It's trying to utilize the DLL files to do some malicious task. And then we see overlay. Now some definitions here first. What is the address of entry point? This is where the actual program starts executing. What is image base, which we saw, the preferred memory location for loading the executable. So the same executable could load on a different memory on my host when compared with your host. The same executable might have different memory, but still there is a preferred memory location for loading the executable, which is the image base. Then we saw the section alignment and file alignment, which is the organization of the sections, how it resides in the memory and on the disk. Then we also saw the data directories, which contains, right now we only see import, but we also get to see export if it's present, especially in a DLL file, we get to see the exports. Under that, there will be mention of functions also. Like if I click on the imports again, and here you see the particular DLL, under this, these are the functions which are getting used. Example, by looking at the name reg create key, reg set value, this looks like registry related, right? And if you click on kernel 32, here are some functions which are part of this DLL and are getting used by the executable, which is the malicious file. Then there is an option called resources also, which we don't see here, but that actually contains something like icons or version information. If we try to load some other executable, it might even contain those information also. Now we'll try to focus on the sections information and try to understand what is the purpose of at least the major sections. The text part contains the executable code. The data contains the initialized data. R data contains read-only data. So the meaning of R actually means read-only data. We can also look for unusual file names when we are looking into the sections. That might also give us some hint and indication about malware. The overlay is the data appended to the end of the PE file. Malware sometimes hides additional code or data here, so it's good idea to look at this information also. DICE also tries to identify known compilers or packers. This can give clues about the file's origin or if it's trying to hide its true nature. If we click on scan here, it ran the scan and tries to identify the kind of file by looking at signatures. But do remember that attackers can manipulate these fields also. So here's a challenge for you. What elements in DICE do you think are hardest for attackers to manipulate without breaking the malware? Drop your theories in the comments. Before we wrap up, let's talk ethics. We are the good guys in this digital battle. So always get proper authorization, user skills responsibly, handle files with caution, respect privacy laws, and stay updated on regulations. We are here to defend, not to cause havoc. That's it for our deep dive into the basics of malware analysis. So keep learning, stay curious, and always be one step ahead of the threats. Before we end this session, let's talk about what's coming up next. In our next video, we are going to dive deep into the fascinating world of computer architectures, fundamentals for malware analysis. We'll be exploring CPU architecture basics, memory hierarchy and management basics, storage systems, file structures, networking fundamentals. To get the most out of the next video, it would be helpful to familiarize yourself with some basic terms if you haven't already. Things like what a CPU is and its basic functions, the difference between RAM and hard drive storage, basic networking concepts like IP address and ports. Don't worry, if these terms sound intimidating, we'll break everything down step by step.